Today we're going to be looking at right triangle trigonometry and extend the ideas that we learned last year in Algebra 2 and the year before that in geometry a little bit further and focus a lot on the connections between the 6 trig functions and the right triangle. Remember, for the right triangle we would use SOHCAHTOA to give us an idea of what trig functions go with which sides. And remember, the word opposite, when we talk about the opposite side, that's the side that doesn't touch the angle we are talking about. The hypotenuse is the side that doesn't touch the right angle, and then the remaining side is the adjacent side to the angle that we're talking about. So it does depend on if I'm talking about this angle down here that I highlighted, or if I talk about this angle up here, some of these values change, and that's what we're really going to focus on today and tomorrow, is how can we relate the two with each other. So first, what we're going to do is find the exact values of the 6 trig functions of this angle here. So this side that's 5 doesn't touch our angle, so that's our opposite side. The side that's 3 times the square root of 6 is the hypotenuse. It doesn't touch the right angle. So then this would be the adjacent side right here, which we don't know yet. So we're going to have to calculate that first using the Pythagorean theorem. Now it's important to note the directions say exact values. So that means no decimals. No decimals. So we're going to leave it in radical form, which does mean we're probably going to have to rationalize some denominators. So first let's find out what that adjacent side is. So 5 squared plus x squared equals 3 times the square root of 6 squared. So we get 25 plus x squared equals, and if we type that into our calculator, that squared goes to both things. So that's why I put it in parentheses. If I just did 3 times the square root of 6 squared, that's going to give me a different answer than doing it the proper way, like that. We get 54. So then we subtract 25 from both sides. X squared is equal to 29. So then when we square root, x equals the square root of 29. And we can't simplify that, so that would be as far as we can go. So this side right here is the square root of 29. All right, so now let's figure out our trig functions. The sine of theta, sine is the opposite over hypotenuse, so 5 over 3 times the square root of 6. Well, we can't have, like I said, the square root of 6 in the denominator, so we have to multiply the top and bottom by the square root of 6, which gives us 5 times the square root of 6 over 18, and we can't simplify that fraction any further. Then let's do the cosine. Cosine is the adjacent over hypotenuse, so we have the square root of 29 over 3 times the square root of 6. We'll multiply the top and bottom by the square root of 6. So 29 times 6 is 174. So we get the square root of 174 over, well, 3 times the square root of 6 times the square root of 6. The square root of 6 times the square root of 6 is just 6 times 3, which is 18. And you can verify that in your calculator if you want. And then our last one, tangent of theta. Tangent is the opposite side, so 5 over the adjacent. Well, we can't have the square root of 29 in the denominator. So then we get 5 times the square root of 29 over 29. Now, you don't have to do it in this order. I always like to do the sine, cosine, tangent first, and then figure out the reciprocal ones. So now the reciprocal ones over here, we have cosecant, which is just going to be my sign flipped. Now, I could flip the simplified one, but that's going to give me a radical in the denominator. Instead, I'm going to take the thing I started with and flip that. So it's going to be 3 times the square root of 6 over 5. Now, another way you could have done it is using this up here. Oh, the cosecant is the hypotenuse over the opposite. And just said, oh, here's the hypotenuse, here's the opposite, and written it as that ratio. But I like to emphasize that cosecant is sine flipped, or the reciprocal of sine. So if we have that, we might as well use it. All right, then we have the secant of theta. That's going to be cosine flipped. So no matter which one we're going to flip, we're going to have a radical in the denominator. So I'm going to take the original one with smaller numbers. So 3 times the square root of 6 over the square root of 29. Multiply the top and bottom by the square root of 29. We get 3 times the square root of, again, 6 times 29 is 174 over 29. And we can't simplify the square root of 174. So we can leave it like that. And then finally, cotangent is tangent flipped. So I'm going to take 5 over the square root of 29 and flip that. Gives us the square root of 29 over 5. So for a lot of these problems today, it's going to be like the same type of process. You have two sides. You have to find a third one, use Pythagorean theorem, and then find the other trig functions. Now here in this problem, I gave you a triangle and I had you find all 6. In example 2, I'm not giving you a picture of a triangle. I'm telling you that the tangent is 5. Well, we know that the tangent is opposite over adjacent. So if the tangent is 5, that means it has to be 5 over 1. And now we can draw a triangle. This is my angle. The opposite is over here. The hypotenuse is this side, across in the right angle, and this is the adjacent. So according to the information I was given, the opposite side is 5, the adjacent is 1, and now we have to calculate the hypotenuse by using the Pythagorean theorem. 5 squared plus 1 squared is 26. So then the hypotenuse is a square root of 26. Square root of 26. Okay, so now we can figure out our 6 trig functions. So sine again is opposite over hypotenuse, so 5 over the square root of 26. Well, again, we're going to multiply the top and bottom by the square root of 26. And I don't think we need to show that step anymore. Like, I think that we could all look at that and say, okay, I know we can't have that square root of 26 in the denominator. Well, we multiply the top and bottom by the square root of 26 is going to give us that. Then the cosine of theta is going to be 1 over the square root of 26, which is going to equal the square root of 26 over 26. We were already given tangent 5 over 1. Now our reciprocal ones, cosecant is going to be easy because it's going to be sine flipped, so the square root of 26 over 5. Secant is going to be cosine flipped, so the square root of 26 over 1, which is just the square root of 26. And then cotangent is going to be tangent flipped, so 1 over 5. So again, knowing your reciprocal identities makes this problem a lot easier. And being able to do the Pythagorean theorem quickly is also essential. So now in letter B, you have the secant is 9 over 4. Well, remember, secant is the cosine flipped. Cosine is adjacent over hypotenuse. So that means secant is the hypotenuse over the adjacent. So the hypotenuse is 9 and the adjacent side is 4. So let's just draw this real quick. There's my theta, there's my right angle. My adjacent side is 4, my hypotenuse is 9. So I'm going to ask you to pause the video and find the remaining side using Pythagorean theorem, and then give me the 6 trig ratios. So pause it and try that. Once you're done, unpause it, and we can see if our answers match. All right, so check your answers here. Remember to rationalize your denominators. You don't need to show what you're multiplying by, so these should be your answers. Now on the next page, we're going to fill in this table with the 6 trig functions of our families from the unit circle. We talked about the sine, cosine, and tangent these values frequently, and we've worked a little bit with the cosecant, secant, and cotangent of these. So we're just going to fill in this table from memory and then talk about some of the connections. So the cosine, so the pi over 6 family, the cosine was the square root of 3 over 2. Whoops. Square root of 3 over 2. The secant, remember that's when you had to flip it and then calculate rationalize the denominator. That would give us 2 square root of 3 over 2. Sine was 1/2. Cosecant was 2. Tangent, because it was pi over 6, it was square root of 3 over 3. And the cotangent is the square root of 3. Now for 45, square root of 2 over 2, and then our secant was just the square root of 2. Sine was also square root of 2 over 2. Cosecant also square root of 2. Tangent and cotangent were both 1s. And now for the 60-degree one, we can just swap the sine and cosine values. So 1/2, which means we can swap the secant and cosecant values. And we can swap the tangent and cotangent values. So I want to focus on the connections between the pi over 3 and the pi over 6 family. And you can see that, in addition, that the cosine of pi over 6 is the sine of pi over 3. So these match up, but the tangents also have that relationship. The tangent of the pi over 6 family is the cotangent of the pi over 3, and vice versa. So we can use these bits of knowledge to actually answer some of the problems without having to find all the information. We can use these are called identities, and we're going to focus more on that tomorrow to answer some of these questions. All right, in our last example, we're going to be using the calculator to evaluate each function, round your answer to 4 decimal places. Remember the mode, because letter A is in degrees, but letter B, there's no degrees, so we're got to change it to radian mode. And letter C and letter D, you have degrees, minutes, seconds. So again, you want to make sure you're in degree mode when you're typing those problems into your calculator. So I'm going to do A, B, C, and D, and then have you try E, F, G, and H. So the tangent, I'm going to make sure I'm in degree mode, degrees, and actually I'm going to do all the degree ones first. So the tangent of 18.5 degrees, we get 0.3346 because we're running to 4 decimal places. 1.3346. And then, like I said, I'm going to do the degrees, minutes, seconds ones. So the cosine of 8 degrees, remember second apps get to angles, 50 minutes, and then 25 seconds. And that gives us 0.9881. 0.9881. Now with the secant, remember we have to do 1 over cosine of 56 degrees, 8 minutes, and 10 seconds. So you could do that part first and get that decimal and then do 1 over that. Or you can do 1 divided by cosine of 56 degrees. 56 degrees. It was 8 minutes and 10 seconds. We get 1.7946. 1.7946. And then we're going to go back and I'm going to change my calculator to radian mode to find the secant of 1.54. So 1 over cosine, 1.54. And that gives us 32.4765. 32.4765. All right, so I want you to try letters E, F, G, and H. So go ahead, pause the video, try those. Remember, G and H are in radians, they're just in pi radians, so you're going to type that part into your calculator. All right, so those are the answers that you should have got when you type those into your calculator. So that's it for today. Thanks for watching. Make sure to like the video and subscribe.